A student measured the length of a rod and wrote it as 3.50 centimeters. Which instrument did he use to measure it? A meter scale, a vernier caliper where the 10 divisions in vernier scale match with 9 divisions in main scale and the main scale has 10 divisions in 1 centimeter, a screw gauge having 100 divisions in the circular scale and pitch as 1 millimeter, a screw gauge having 50 divisions in the circular scale and pitch 1 millimeter. Okay. Now, first of all, let us try to get the number of significant figures in 3.50 centimeters. Can you tell me how many significant figures are there? 3. No, 3. Last one is important. 3 significant digits or figures. Okay, which means he or she must have measured this length with a device whose least count is 0.01 centimeters. Have you understood this? 0.01 centimeters. Right, otherwise if the device had been more sensitive, he would have written 3.500 centimeters, but he has not. He has written 3.50 only. Okay. Now, can a meter scale have a least count of 0.01 centimeter? What is the least count of a meter scale? No, 1 millimeter. Right? 1 millimeter is the least count, or a tenth of a centimeter. Is that clear for a meter scale? Which means the answer should have been 3.5 had he used meter scale to measure it. Make sense? And not 3.50. Okay, let's go to B now. Let's go to B. A vernier caliper where 10 divisions in the vernier scale match with 9 divisions in the main scale, and the main scale has 10 divisions in 1 centimeter. Now look, main scale has 10 divisions in 1 centimeter. That means each division on the main scale, let us use the standard notation, x will be 1 centimeter upon 10, so that is 0.1 centimeter. This is not the least count, please keep that in mind. This is the length or the distance between two consecutive divisions on the main scale. Okay, now let us read this part again. 10 divisions in the vernier scale match with 9 divisions in the main scale. Now let us see if we can get something from this. 10 divisions in the vernier scale, so 10y match with 9 divisions in the main scale. Okay, we have just now solved a problem on this, so this is a similar relationship. Got it? So what is y? Y is 0.9x. Okay, and what is the least count now? Least count is x minus y, always x minus y. So x minus 0.9x, x minus 0.9x. So how much will that be? 0.1x. But how much is x? 0.1 centimeters. So it is 0.01 centimeter. Now does that match with the answer that we have written here? Yes, it does. Which means the correct option to question 17 has to be option B. Is that clear?
Yes, sir.
Now let us try to find out the least counts of the screw gauges in options C and D. Let's go to C now. Okay, let's go to C. A screw gauge having 100 divisions in the circular scale and pitch as 1 millimeter. Now pitch 1 millimeter means if the screw completes one full revolution, 360 degrees, it moves forward by a distance of 1 millimeter. So for option C to be right, okay, or the least count in option C is 1 millimeter. Let us write it in terms of centimeters. So 0.1 centimeter divided by 100. Okay, so 0.001 centimeters. So that's not what we want. Otherwise, our answer should have had 3 digits after decimal point. Okay, and D. What about D? A screw gauge having 50 divisions in the circular scale and pitch 1 millimeter. 50 divisions. Okay, 50 divisions means, pitch is same, 0.1 and 50. Okay, so what should we be doing? We should be multiplying this by 2, so it will be 0.002 seconds. This is also not right. Okay, this is also not right. So the correct option to question 17 is B. Have you understood this?